In this question, it is given that let matrix A equal to this and matrix B equal to this, where I means under root minus 1. If M is equal to A transpose into B into A, then the inverse of the matrix A, then the inverse of the matrix this is, you have to find the correct choice. You have to find the correct choice. In this matrix A point to be noted about the matrix A is, you can see very easily this into this plus this into this is 0. This into this plus this into this is also 0. And value of determinant of this matrix is 1. And in such a matrix, remember that A transpose is equal to A inverse, and such a matrix is called orthogonal matrix. Hence, in this matrix, A transpose into A will be equal to I. And now, keeping this thing in mind, if I want to find M square matrix, M square means A transpose B A into A transpose B A. And associative property of matrices says that provided you keep the order of matrix same, you can multiply any two matrix first. I write it as A transpose B A into A transpose B A. That is A transpose B square A, because this will become I. That is M square is this. Similarly, it is easy to check that M cube will be A transpose B cube into A. Hence, I can say A into M to the power 2023 into A transpose is equal to A, and M to the power 2023 will be A transpose B to the power 2023 A into A transpose. And again, using associative property, you can multiply any two matrix first. That is, I can write it as A into A transpose bracket B to the power 2023 A into A transpose. And because both are I, hence I can say B to the power 2023. Hence, this matrix is equal to B to the power 2023. Note that whenever in some question a high power of matrix comes, to simplify that matrix, you can take the help of Cayley-Hamilton theorem. In the case of 2 by 2 matrix, no need to go by general way, because using Cayley-Hamilton theorem is good for 3 by 3 matrix or higher order matrix. For 2 by 2 matrix, to evaluate the any higher power of B, it is slightly better to go by symmetry. But for your clarity, I will do this part of the question by both the ways. In this case, if you want to use symmetry, because we have to find the value of B to the power 2023, first I find B square. That is 1 minus I 0 1 1 minus I 0 1. This is equal to minus 2I 0 and 1. Similarly, if you find B cube will be equal to B square into B, that is 1 minus 2I 0 1 into 1 minus I 0 1. This is equal to 1 minus 3I 0 1. You can see very easily in every next step this will be increased by minus iota. It's not difficult to see and it is obvious. In this way, clearly b to the power 2023 will be 1 minus 2023 iota 01. And otherwise we can find the value of any higher power of matrix using Cayley-Hamilton theorem also. Agreed, it is not very good way here, but it is a general way. If you are dealing with 3 by 3 matrix, then this way is better. And first let me tell you the meaning of Cayley-Hamilton theorem. Cayley-Hamilton theorem says that every square matrix satisfy its characteristic equation, and characteristic equation is found by, and characteristic equation of any matrix say X is found by X minus lambda I equal 0. Opening this determinant, you will be getting a equation in lambda, and that equation in lambda is called characteristic equation of the matrix X. And Cayley-Hamilton theorem says that matrix X will satisfy its characteristic equation. And because I have to find a higher power of B, therefore first I will find the characteristic equation of matrix B. That is, I will find determinant of B minus lambda I equal to 0. That is 1 minus lambda minus I 0 and 1 minus lambda equal 0. That is, we subtract the number lambda from all the diagonal elements, keeping all other elements same. This is the value of this. And if you open this determinant, you will be getting 1 minus lambda whole square equal to 0. That is I can say 1 minus 2 lambda plus lambda square equal 0. Note that you will not write it as this implies that 1 minus lambda equal 0. After this step, don't go in this way. And after this, because in matrix algebra, if A square is 0 matrix, it doesn't mean that A is also 0 matrix. And because this is the characteristic equation of matrix B, B square minus 2B plus I is equal 0. That is B square equal to 2B minus I. And now to find B cube equal to 2B square minus B, and B square is 2 into 2B minus I minus B. That is, I get 3B minus 2I. This is B cube. Similarly, if I want to find B to the power 4, B to the power 4 will be again multiplying by B. I get 3B square minus 2B. That is 3 into B square is 2B minus I minus 2B. That is again you can get 4B minus 3I. And keeping this symmetry in mind, I can say B to the power 2023 will be equal to 2023 B minus 2022 I. That is, it is 2023 1 minus I 0 1 20 22 0 0 20 22. This is equal to 1 minus 2023 I 0 and 1.